All right. So this is assignment time. Now we are going to do some questions, hands-on practice with the matrices on MATLAB. So let us just start. Question number one. Use the magic function to create a square matrix of order 6. Simple. Let us just create one matrix here. A is equals to magic of 6. Done. Next is A part. Now use sub2int function to generate the linear index for following positions of elements 1, comma 3 and 2, comma 5, 5, comma 5. Try back the subscripts to indices back. All right. So we are going to use sub2int function to generate index values. So first row and third column, let us see what is the index value for, let's say I'm using Z here, sub2int. Firstly, we are going to use size of A. This is our matrix, comma, 1, comma, 3. So what is the index value? It's 13. Okay. And in a similar way, 2 comma 5, 5 comma 5. So here I'm repeating my statement. I'm just changing it. 2 comma 5, 26. Okay. Again, 5 comma 5. It's 29. So this is how you can get your index values with your subscript values. We have discussed earlier also that subscript value and index value are belongs to the position of the thing in our matrix, the value of the position. Okay, so next question is change the value of above indices randomly. So how can we change the value? We have discussed this earlier also. So we are using, let's say, okay, so I'm going to change the value, index value. Let's say I'm taking A29 and what is the value there? It's 14. We can check what is the value and how we can change it. Let's say I'm making it 40 and 29. This is 29 and previously it was 14 and I have changed the value to 40. This is how you can change the values. And okay, the third one is insert a new random element in 7th row and 7th column of the above matrix. So how can I create a 7th row or 7th column in a 6 cross 6 matrix? Let's see. So my A is magic of 6 again. Okay, what I am using? I'm using subscript value 7 comma 7 is equals to, let's say I'm putting 1 here. What happened? Now 1 is at 7 comma 7 and other values of 7th row and 7th column are 0 0. And to confirm this, we can use size of A. It's 7 comma 7. So this is how you can add your subscript positions to your matrix and their values also. Okay, so the next is use the size function to find the row and the column in the new row and column matrix. So we have already used it. Size, it is 7 comma 7. All right, take the transpose of the new row and column matrix. So how can we take, let's say I'm taking B, A transpose, A transpose. This is transpose sign. Okay, all the rows have become columns and columns have become rows. So to just check, okay, 31, 35, 1, 6, 26, this row has become this column, 35, 1, 6, 26. Okay, so next question. Okay, we have done this first question successfully. Now jump over to second question. Use the matrix reshape function to resize any matrix in the following manner. Okay, so we are going to use reshape function here. Reshape the matrix into a row vector and then into a column vector. Okay, reshape this matrix into a row vector. How many elements? There are 49 elements right now. Okay, 49 elements. So how can we reshape it? How can we make it as a row vector? Let's say z is equals to reshape a, no, a, not a, we are using b here, and there are 49 elements. So one row and 49 column. Correct. Now, can you see Z is equals to 1 cross 49 double? We haven't discussed what is double, but just uh, take a idea that double is integer precision, or you can write the float values as well in it. So we have 1 cross 49. This is a row vector. Okay, so just convert this into a column vector by using a reshape function. So okay, I'm going to use my reshape function again on B, and this time my rows will be 49 and 1. Now this, see, this is my column vector with 49 cross 1 double. Okay, so the next question is reshape the same in matrix into a matrix of 3, 12 and 4, 9. I think we have discussed this thing. We already have done this thing. Here we are going to use some like 3, 12. Okay, what happened? Oh, it's a 7, 7. B is where I'm applying it. It is a 7, 7 matrix, and 3 into 12 is 36. So this is for 6 cross 6 matrix. So let us just change this B into A. No, A is also here. Oh my God, A is also 7, 7. So let us just call one function magic 6, and again reshape A with 3, 12. So there are 3 rows and 12 columns. I have reshaped my matrix. Done. All right. So the next question is, you can try this. You can try this at your own practice time. All right. So question number 3 is create a 4 cross 5 matrix. Okay, how can we create a 4 cross 5 matrix using magic? Is it possible? Let us just check. Magic of 4, 5. Is it possible? No, because matrix created by magic is always a square matrix, and we cannot like create a rectangular matrix with the use of magic. So which function we are going to use here? It's random integer value, and it will ask you for the maximum I max value. I max, let us assume that 30 is the I max value, and none of the value including all the elements will not be bigger or greater than 30. So it will create a rand I matrix, and let's say I'm using it as C. Okay, now this is an integer matrix, rand I, random integer, but I max value is 30. So none of the element is greater than 30. So for this, you need to mention I max value. All right. So, okay, we have created it. Now what to do with this? Use min function first, and to find out the row vector of minimum values. So, okay, let us just put a min function on it. Min on C. I'm applying min function on C, and I'm creating Q matrix for this. Okay, we have got one row vector. It is a row vector. Q is a row vector. Nice. And all the minimum elements of that column, 3 and then 5, again 5, and here 13 is the minimum element. Okay, so this is how you can get all the minimum values from columns. This shows that MATLAB will always work on columns, not on rows. Okay, how can you get the minimum value from the row? For that, you need to transpose it. Let's say I am using Q1. It's C transpose. All the rows have become columns and columns have become rows. You can compare them. Okay, first 25, 28, 4, 8. 25, 28, 4, 8. Okay, transpose done. Now you can again apply min function on it. Q1. All the minimum elements from the new columns, which were the rows previously. So these are the minimum elements. Likewise, you can apply max also. Maximum elements. Okay, so this is how you can apply different functions on your matrices. Apply the same min function on it to find the smallest of all. So how we are going to get smallest of all? We are going to apply min on ANS. ANS is my answer, and this is 25, which is the smallest of all. Okay, hope you get it. And next step is all right. So the next question is find out the minimum value of all the elements in one matrix in one step. Let us just do that. All right. Then my matrix was magic of, no, not magic. I cannot use magic with 4,5 because magic always gives square matrix. All right, so how can I find it in one step? Min of C. So the lowest number, the minimum number is 1. Please apply all these kind of operations with the max function also. Try it yourself. Let us just jump to create a row vector of 1 cross 100 in the following different ways. Use the general command to create a row vector of 100 elements. At least count 0.5 elements. So I need to create 1 cross 100, a row vector with the least count, or you could call it as the step size of 0.5, but it should be 1 cross 100. So let me take linspace function, and I am using 1, 100 with interval of 0.5. Will it be Okay, it is an empty matrix. Why it is an empty matrix? Because we cannot create it with a linspace. See, this thing you should understand where to use a linspace or where to use a colon operator, because both of them are used to create the row vectors, but here the least count is zero point 0.5. That means only half number I want to print. No, linspace will give you the number of points. It's zero point 0.5. So basically it has given me zero number, which is empty matrix. So it is very clear that I'm going to use 1 colon 0.5 colon 100. It's a step size, a least count, you could say. All right, it has given me some row vector, and let us just see what is the size. 1 cross 199, but I want 1 cross 100. So there was no limit, which is for the upper bound was decided. So I am taking it 50. All right, now they are 99. 1 cross 99. One more point with the least count of 0.5. So I'm using 50.5 as my upper bound. So okay, now this is 1 cross 100 row vector, which was my requirement, and the least count is 0.5. The 0.5 gap in every single element. As you can see, 0.5 is the minimum least count. All right, so this was the first question of fourth question. Convert the above row vector into a column vector. Very simple, we can do transpose. Use linspace function to create the column vector of 100 elements with, okay, by using linspace function. They are calling it with a linspace function, and there should be 100 elements in between 0 and 500. So here we are using it, linspace 1 comma 500 comma 100. Basically linspace gives you the number of elements, and it should be in between this limit 1 to 500, the 100 elements. So what it will give you, it will give you the 100 elements, correct? But what is the difference here? Here the least count is not decided. Instead, the least count is equidistant, equal least count in between every element. If you just do subtraction, you'll get a same answer every time. Okay, so this is the function linspace. So okay, one thing I want to mention here, can you see it? Every number is the 4 decimal places. So this is precision. Precision means the accuracy. In calculus, we used to call precision as a accuracy. So we are using it 0.4 decimal places accuracy in MATLAB by default. And if you want to make it large, make it format long. What it will do, it will give you 16-bit decimal place accuracy, the precision. Let us say I am writing pi over here. A is equals to pi. So what is the value of pi? 3.14 usually we take, but it is like 16 bits above than this. So it will give you the accuracy, the precision more than that. If you want to come back to your short format, you can come back to short format, short. And again, if you write a is equal to pi, it will give you 4 decimal place accuracy, as you can see here. Okay, so this was the basic thing when you are working with the precision values in the calculus, linear calculus, linear algebra. At that time, if you want more accuracy, you can use format long, or if you want Okay, 4 decimal places accuracy, you can come back to short. By default, MATLAB use short precisions. Okay, so the next question is done. Fourth question is successfully done. Now, fifth question, create two vectors x of order 1 cross 5 and y of order 1 cross 5 and then perform following operations. As you know, we have done relational operators and logical operators in our class also. So I'm leaving this question for you. Just create the row vectors and compare them. Come to sixth question now. Okay, create a 6 cross 6 matrix, use rand n function and then insert ones in the matrices in the row 2 to 4 of the matrix. Okay, let us just enter rand n matrix. P is equals to rand n. N means normalized matrix. Rand n 6 cross 6 matrix. Rand n means near to 0, near to normal. X and y both are normal to each other. So near 0, near origin, it will give you the points. It is normalized matrix. Random numbers will come every time. So what are they saying? They were saying from second row to fourth row. Second row to fourth row. Make them ones. Is that the question was? Let me, yes, second to fourth and insert ones. Okay, so I am using my colon operator again. P is my matrix. How many rows? 2 colon 4 rows. Comma. How many columns? All the columns, right? All the columns. So how can I write all the columns here? Just put the colon operator and it will consider all the columns. After comma, there are columns. So if you put only this colon operator, it will consider all the columns here and equal to ones bracket. What is the size of my matrix? 3 colon 6 because 3 rows and 6 columns. So I'm putting ones at that place. Okay, 1 1 1. Can you just see if I have entered 1 1 1 at the place here? So easy. So this is a new thing. That's why I discussed it here. Okay, with the random value. Okay, we have done this. I think with the random value 6 cross 6 matrix should be generated and the maximum value should be 30. We have done this already. Rand I was the predefined function. Maximum element should be 30 and it should be 6 cross 6 matrix. So 6 cross 6, you don't need to write 6 comma 6. It can work with 6 only. So it is obvious that it will give you a 6 cross 6 matrix here. So, all right. Next question, which is the nicer one. So, sorry for that. Okay, delete all the even index elements of the above matrix. Suppose we have this matrix, 6 cross 6 we have generated. And delete all the above even index elements in above matrix. Even index element means this is 1, 2, 3, 4, 5, and 6. So even index elements were 2, 4, 6. Likewise 8, 10, 12. So I need to delete all these elements. Okay. I'm not changing them. I'm just deleting them. How can I delete them? My matrix is A and S right now. So from 2 till 36 and the interval should be here 2 means from second index element it will start and every second element like this interval is showing me It is jumping and going to second one, then next second one, next second one, like this till 36 index elements. It will jump like this. And what I am going to do is I am going to delete them. Just put this empty matrix in front of it. Okay, so here we have 18 elements left. Initially it had 36 elements, so now we have 18 elements only. This is my size now. Initially it was 36. Okay, and it's a row vector. Why it's a row vector? Why it is a row vector now? Because it was 6 cross 6 matrix and you have deleted the elements with their positions, particular positions. So what left, it will give you a row vector as an answer because these things are left. Okay, this was the nicer one. So next thing is use function root 90 flip LR flip UD on any matrix A and see the results. This is just to see the results. Nothing to do in this question. So, okay, we are doing it. Let us say I have magic of 3, enter. So, I am just using root 90. Root 90 on A. Okay, so what happened? It has been rotated 90 degrees. See, the 6 is here, 7 is here, 2 is here. So basically what happened, it has rotated 90 degree, all the elements. Okay, so this is how you can see the results of flip LR and flip UD. Please check out them. And this finishes your matrices and array operations. Array means that multidimensional matrix. We called it array. So this finishes your matrices and array operations. In the next class, we'll go for data types. What kind of data matrices or the MATLAB elements can have, and on what kind of data MATLAB can work. So this is all about matrices. Thank you so much.